Huh? If it works, yes. Okay. Ah, okay. I sent you the link. If it works, let's use that. If it's not, then it's offline and rumors. I sent the link on your Telegram. On Telegram. Okay. So you should have the link. Cool. And it's also on the GitHub page. Okay, guess we're gonna get started. Do you wanna hand out those people? Okay, welcome everyone. Let's get started with the Thing-to-Thing research group session. So as usual, since we are in an IETF meeting, the Notewell applies. This is the short version of the Notewell. There's also now an updated, longer version, essentially says the same thing. IPR rules of IETF, they apply also in the IRTF side. You are being recorded and be nice to each other. And the goals of the IRTF, it's good to remind that now we are on the research branch of the organization. So here our idea is to conduct research instead of do standards. But of course, we do a lot of collaboration with the IETF. So we are discussing a lot of things that are related to standards. But here really our goal is about advancing knowledge and sharing the knowledge about topics relevant on IoT at the IETF. So the pink sheets, or nowadays blue sheets, are going around. Thanks for volunteering note takers, Niklas and Ivalo. Anyone is also free to chime in on the note takers on the Etherpad online. Let's hope it works better than earlier this week. Is anyone using Jabber? Okay, if you can also, just in case, hang out at the Jabber room, see if we have anyone chiming in on the chat room. As usual, you will find our daily activities and more information at our mailing list. And we do share all the materials as usual at our GitHub repository. We have had one repository per meeting. You can find the information about this meeting in particular at the GitHub repo 2019 IETF 106. Agenda for today, we are now in the introduction part. I will give a quick update on the research group status, what is upcoming meetings and activities. Then we will have reports from our other activities, including Wishy, a meeting we had on Friday before the IETF week, on the hackathon, and quick one on the core application site meeting. After that, Michael Koster will give us an update on the activities on IoT data model convergence, in particular one data model. Michael McCool will give us an update on W3C Web of Things. And finally, we have reserved a quite substantial slot towards the end of the meeting for discussion about this general IoT operations, security management of onboarding lifecycle, etc. A potential for a new group or activity at the IETF for looking at the IoT aspects at large. So this is a discussion that has been going on for a while now. Our IoT Directorate, and also this meeting during the site meetings. And we'll, in this slot, would like to share some of that discussion and engage the wider IoT IETF community. So Michael Richardson and Elliot Lear will be driving the discussion over there. Any agenda bashing questions or comments? Okay, then we'll get started. So that's a reminder of the T2TRG scope and goals. So as mentioned in the beginning, this is the research arm. So we are working on the research issues, turning the IoT into reality. And in particular, what we've been focusing on is these low resource nodes, things or constrained nodes as they're commonly called, how they can be part of the wider internet and wider IoT. We are focusing here on things that have relevance on the IETF standardization. So if you think about stack-wise, we start roughly at the IP adaptation layer, sometimes looking at the connectivity aspects, but go all the way up to the application layer, including architectures, APIs, management, and of course, security. How we really relate to the groups on the IETF side, I mean, there is a lot of overlap when it comes to IETFs. So where we look at this research issues, for example, taking two groups that we have a close collaboration on the IETF side, Core and LWIC. In Core, we're doing a lot of the RESTful protocol data model design that sometimes originates from the RG side, sometimes comes from elsewhere. But then sometimes at Core working group, for example, we come across some issue that we realized, okay, we are actually not ready to do really the standardization on this. We should do a bit more thinking, architectural considerations, etc. And sometimes then work moves from the core working group or other working groups to the thing-to-thing RG side. In a similar fashion with LWIC, which is focusing on giving guidance on implementation on the IoT aspects. And then we have, of course, other groups like IoT Directorate looking at coordination across IETF groups and beyond. And also in T2TRG RG, we have been traditionally doing a lot of coordination work with other SDOs, including OMA SpecWorks, OCF, and T2TRG, for example. So in addition to this meeting, which we commonly call a summary meeting, we have had other related activities at IETF 106. We had on Friday a pre-meeting with T2TRG Web of Things at the National University of Singapore. So one more slide coming on that in a moment. And also there was a core application site meeting on Tuesday where we're discussing the problem details for co-op APIs and error responses. There will be drafts coming on both topics, likely on the core side, but will very much related discussions also happening at the RG side. So a few words on the workshop we had on Fridays. This was a joint work with T2TRG Web of Things. What we were focusing from the RG interest, we have had generally 6 interest areas where we're looking at in RG. And out of those, basically 3 were mostly in the scope of this workshop, which we also commonly have in the scope of the WIShy activity. So modeling data interaction for IoT, REST-based hypermedia for IoT, and also connectivity for IoT. So there was a discussion how T2TRG Web of Things, what is the status there, where they're going, and also how things relate to what we do at the IETF side. Quite a lot of discussions on one data model, what is status there, how things relate together, how Web of Things thing descriptions relate to one DM, and how it all comes together in a bigger architecture. And then also on connectivity, how things like MUDs, for example, can be used to give more semantics on the connectivity you're trying to establish, or how you could, for example, use protocols like ICE in a constrained environment, and what are the semantics on when you exchange candidate information data in that kind of environment. But there's a whole host of notes coming on that, which still need to refine them, but once they are published, we'll let you know on the mailing list. But all the materials are already available on the GitHub repo of that meeting. Going forward, we have had usually these WIShy calls, couple of them between the IETFs. We are planning to go roughly monthly pace on those. December looks rather booked already, so probably we'll kickstart that in January, but there's going to be notifications on the mailing list. We have had traditionally virtual meetings, OCF, OMA SpecWorks, T2TRG Web of Things occasionally on the topics that we have common interest. We will likely to continue those. And then we have had almost every IETF a joint summary meetings happening. So likely we'll have one in Vancouver. And in particular, the hackathons, we have been very active, already 7 of them or so far. So we'll most likely have a WIShy hackathon activity co-located with the IETF. Also, we have been very interested in having co-location with academic conferences. We haven't had too many recently. So if you are aware of or even potentially organizing a relevant academic conference or other activity, we'd be very interested on co-locating with you. So please do approach us chairs and let's talk about it. Then moving on to the status of our work. while our research group don't necessarily produce RFCs, we have been having some tradition of trying to document the major outcomes of this group in drafts. So we already published one RFC about security. Right now we do have one research group document on RESTful design for IoT. I'll give a bit more details in a moment. And we have a set of documents that are upcoming, are not currently research group documents, but are something that we are considering for adoption. In Portugal, there's one active work on Edge and IoT. We'll have a short update in a moment. Also on secure bootstrapping for IoT, UP. And then on core applications, there have been discussions, probably going to be documents either on the core side or on the research group side, potentially both. On some considerations on layer 3, there has been discussion we should document more aspects that are relevant there. And then also on Wishy, what we've been calling Wishy nodes, we might be coming something up on a particular data model versioning and semantics area at large. So a few words on the RESTful design. So this is one of our long-running research group documents. We did an update for this IETF, added information on Coral and constrained URIs, those two technologies that are now being developed on the core working group side. How do they fit into the larger architecture and on the RESTful IoT? And also we added a mention of how you use server push mechanism configured with core DynLink. So core DynLink again is a mechanism we developed at the core working group side. We are now considering should we add some more information about affordances and also on discovery side. But overall, we're thinking that this has been becoming a rather stable document, not much updates coming. So we should probably do a request for publication soon and get it done with. A quick update on secure bootstrapping for IoT. I asked from the authors what's the current status. Seems to be it's rather same that was on the last IETF, so documenting the device bootstrapping terminology and relationships, identifying some common design assumptions, and investigating benefits and challenges of EAP. There was no update for this IETF, but there should be one coming for the next IETF meeting. And then on the quick update on the Wishy activity. So this is you could think of a sub-activity on thinking research group, focusing kind of on the top of the stack. So as the name implies, on semantics and hypermedia interoperability. We had two meetings between the IETFs. There was one face-to-face work meeting, because one DM had a 3-day face-to-face meeting in Kista in Sweden about a month ago. So we had a face-to-face Wishy workshop right after that meeting. On that meeting, what we did, we focused on the one DM topics because they were still fresh in mind, and there was some interesting architectural and research considerations to be think about. So we did think about the architecture and terminology, discussed like how we get some more alignment there on a bigger picture. And in particular, the JSON pointer and semantic breadcrumbs was a topic that was discussed in quite in detail. And then further on, the processing model, how do you handle one DM descriptions and how you turn them into something useful in other contexts. We did also have one Wishy online meeting a few weeks before the IETF. There, our key focus was on data model versioning. So this is a topic a lot of IoT organizations seem to be hitting right now. You make your first version of data models, then you realize, maybe there are some things that should have been done slightly different way. What is a good way to support this evolution? And versioning is one mechanism what we have been using in the past, but of course it has some challenges. And in particular, in this discussion, we're focusing on what are those challenges and how are perhaps better ways to achieve the evolution aspects. So we are planning on a Wishy note on that aspect right now. And there's also a lot of material in the meeting notes from that discussion. And also, of course, one data model and hackathon activities that were focused on this online meeting. Then to give you a quick update on the Wishy hackathon. So as I mentioned, we'll be having these hackathon activities already 7 times at the IETF hackathons. In this hackathon, our plan was to focus again on the data model convergence. It's quite similar to last IETF. And in particular, translation using the one data model tools and models. Also, since we had this joint activity with T2TRG starting on Friday and going on actually for years, we were working together with Web of Things. They had their Plugfest, and they were planning to work on integration of core resource directories to further on support discovery capabilities in the Web of Things context. And then already as the past few IETFs, we've been working on this UP, Young-based conversion for binary to CPOR enhancements, but Ivalo will give a closer update on this. So what did we achieve over those past 2 days? So as I mentioned, big activity was around this one data model tools and concepts. So we've been working on conversion tools to move between live with MTM IPSO models and one data model models automatically, so that you wouldn't have to do that kind of conversions ever manually. Already at the previous IETF and hackathon, we did have a first version of going from IPSO to 1DM. We did enhance that conversion too, but we're mainly focusing going from 1DM to IPSO. And it seems that we can do mainly lossless translation between these two models already right now. Also, what we did is enhance this data model linter. So it's very convenient to have tools to actually check that your conversions make sense and have automated tools in general. It's very helpful in this context. So what we did use these tool sets also to set up a automated continuous integration in the GitHub of 1DM test repo, that whenever there are new submissions, they are automatically tested. They actually do conform to the guidelines and style set up for that. So all those 3 tools, they are available as open source contributions, and you have the GitHub URL right there if you're interested to have a look at the details. In addition to hacking, we also had very good discussions on architecture, how we use semantics, how can we deal with dynamic descriptions of things and data models, and overall, how do we get convergence across SDOs? Because of course, a lot of SDOs are working on very similar topics. How do we get more and more convergence across those so we have better interoperability going long term? On the T2TRG Web of Things topic, there was now a first version of thing description discovery using QAP-RD up and running. That was also a good success, and also we have good progress made on UP, but Ivalo will tell you more in a bit. One thing that we are discussing going forward, how do we bring these things together, was that how can we take from 1DM SDF descriptions to create thing descriptions, perhaps we're using some RDF tooling in between, and then be able to expose these in what we are now calling a semantic proxy that would enable to use applications and devices from different ecosystems, and then working together using a proxy or a gateway. But Michael Koster will be going in more details on this on his presentation slot. So that was a quick update on the research group activities. Any questions, comments on those? Okay, in that case, let's Ivalo and Yupi.
Hello everyone, my name is Ivalo Petrov and I will present you the advancement of UP. So a little bit of context, in some networks like AP1 and other constrained networks, quite often we use binary formats in order to send data. And it could be Modbus, it could be some other proprietary formats, but those payloads are rather difficult to use in other systems. And in order to improve interoperability, it would be good to have a common way to express how the binary data could be parsed into JSON, CBOR, or something else that different systems could use directly. So this is the goal of UP, and what happened during the hackathon was I implemented part of the encoding. It worked well, and there are still some parts from the encoding that are not implemented, but so far there were no difficulties. I looked how we can express parsing QAP and different other different formats in UP, and the autoencodings are rather unattractive, so to speak, but I think I managed to get that done using expats, which are part of Liang. So no magic there. And I looked at Modbus, which seemed to be rather easy. So I think I'll be looking a little bit at some concrete examples to see that everything works out well and that I can implement some applications with UP. The differences in the draft are I introduced when statement and expat expressions in case we need to express more difficult or more complex parsing. There are other details about list length definition before that was to be defined. Now the built-in types are explicitly listed. There are details about how string values could be mapped to numbers, namely using enumerations, and try to improve the readability by moving some things around. So my idea for steps forward is to implement some real example using Modbus, maybe have some, I don't know, lights or some other actual devices that use Modbus and implement usage of that with UP and see what are other examples that we want to use, get any feedback, some feedback hopefully, and take it from there. So that's it. Any questions, comments?
Okay, thanks, Ibala. Do we have next, Matthias? And Matthias, actually, we are well on time. So we are actually well on time, so no need to rush time.
Okay. We are well on time, I heard. I'm Matthias Kovac. I'm presenting the IoT Edge Computing draft, also on behalf of my co-authors. So to look a bit back, so this draft originally started as basically providing use cases and examples how edge computing can help IoT. We saw a growing interest with this. So in Prague, actually, we had a discussion at one of the T2TRG pre-meetings, and a number of new authors joined. And in the last meeting, this was then actually also merged with already existing work. So Dirk and Yves did some work on a survey of edge computing and a gap analysis. This was merged in the document. So basically what you can see is that the draft has evolved quite a bit. So starting from just listing, okay, there are interesting use cases, we actually moved forward to some gap analysis, which should be the ultimate goal of this draft, basically to identify white spots. Is there something that needs to be done so that edge computing becomes really useful for IoT? So what are the major updates for the version that we submitted shortly before this IETF? One part of the work actually went into operations. So we converted everything to Markdown and moved to GitHub because we now have actually quite a number of authors around the globe. So this smooths hopefully a bit the way forward to work on this. The major changes that we did is one is that we moved from the edge architecture that was originally described in the document to models. The reason is we do not want to promote or preclude certain architectures, but it's really about, okay, this is what you find in the wild, and this is how edge computing is useful to solve your IoT problems. And the other major change was that, we moved from showing just, okay, those are use cases, this is what you find out there, more to function analysis. So we really want to see, okay, what are those functions that you need from the edge? So Carsten had a very nice example that, for instance, the smartphone became a very good device to configure new IoT devices. but what is the equivalent? What is the box that we use, for instance, if an IoT device needs to store data, maybe needs to offload some computation? How do you do that? Other management functions. A new hot topic in general is onboarding. Maybe there's also some benefit if you have this, for instance, on premise. And this is what we want to do ultimately, to basically look at what are the different functions that you need, and then do this gap analysis or show the white spots where there's potential work for IETF. So we met at this IETF, so the authors met, and we discussed basically several to-dos. So we have quite some homework for now. So some of the things need to be written better out in the document to actually arrive at these goals. And we set ourselves a timeline. So we want to update the draft with what we discussed by around Christmas, so that we can actually gain feedback and get some reviews in early next year, so that we can get out a new version that then includes this feedback by next IETF. May I ask the room who has interest in reviewing this document? And then maybe someone who can note this down. See, 1, 2, 3.
Matthias, I'm also interested.
Okay, cool. Thanks, Michael.
In fact, I'm interested in participating more actively. I'll probably be at IETF in Vancouver as well.
Okay, very good.
Can you put up your hands again, because I would like to record names. Marie-José,
Right, and Michael
No
McCool.
facial recognition. No facial
Eric,
recognition, so you
Elliot.
don't know who we are.
Yeah, and Michael McCool.
Thank you.
And I think this question was out there with the adoption for an research group document. Since we had quite some change and also want to implement this change more clearly now, we decided let's get a few more versions out there that we are, as authors, are actually really happy with it, and then post these questions again.
Eric, not Mark. So there's an open source or a set of open source projects happening under the Linux Foundation as part of something called LF Edge. So since I'm working in that space, I'll take a look at, terminology and other things that might be able to harmonize a bit. But I had a question about the draft. So the draft, I see it has a few use cases in there. Are you planning on keeping those, expanding them? Because as far as I know, there's like gazillion use cases, right?
Exactly. So yeah, that was that we definitely want to look at real world use cases, but then focus more on the models that you find in there. So basically universal patterns that can be applied, but not give you the complete list of use cases or solutions out there.
Okay, thanks.
Maybe one comment, we have quite an extensive appendix at the moment that lists projects that are out there and gives a quick introduction. I think we have to see how we deal with this if you really want to have this huge appendix. As you said, it's a gazillion.
Marie-José Montpetit with the COIN co-chair hat on. I think this would be interesting work to do, like maybe in collaboration with us, because there seems to be a lot of commonality in terms of the edge and the discovery of computation and data and storage. So I think we should talk about maybe you presenting to us at a future IETF, maybe in Vancouver, and maybe do some things together.
Yeah, so in fact, I presented this in Prague, I think, also to address and make people in COIN aware of this. We also actually discussed yesterday that we should talk more about the network as something that could be discovered. So what modalities are there. So once we have this in there, it's definitely good to also maybe ask for reviewers in COIN, to keep the two groups together, because it's related to both.
Yeah, I think it is. So I think we should move forward with this. Thank you so much.
Okay, thank you.
Yeah, and likewise, that's my interest. Is I'm doing work on discovery and Watt, and I think there's some heavy overlap between edge computing and Web of Things.
Very good. The interest grows further. Okay, I'm done.
Excellent. Thank you, Matthias. So this ends our first slot on the overview of activities and documents. So next we have a Michael Koster remotely presenting the IoT data model convergence. Michael, please go ahead. And Michael, if you're talking, we cannot hear you right now.
Yes. How about that? Does that work better?
Now it's better. Thanks.
Okay, great. I had to click a button here to do that. So how do the slides work?
If you are in the presenter mode, you could also present there, or you just ask me to put the next slide, whatever works for you.
So I'm in presenter mode, and I can advance the slides then with the button somewhere. I see the slide.
Probably it's easier if you ask me to put the next slide on.
Okay, so please, next slide. So I would talk about two activities that are going on. In the past, we've talked about IoT schema.org, and that's what we're calling now IoT extensions for schema.org to make it clear what we're doing. And then now the one data model that I think I've talked about maybe one time before. So slide, please. So one data model, to refresh people's memory, we're not an organization, but we're a sort of a federation of organizations that are working under a liaison agreement. And initially what we're working on is a common language for how we express semantic models for IoT that's simple enough to be usable by application domain experts. So you don't have to become a modeling expert. And also eventually we want to use this for converging the definitions of common IoT device types, so that someone wanting to create a device type using some common patterns has a model that already exists. Right? Next slide, please. So the history is it came from in the fall of 2018, so we've been working about a year. And there was a good cross-industry consensus that common data models were what we really needed to go after as the next key inhibitor for IoT growth. So we work in the open mostly. We work, at least the tools are in the open in a GitHub repository. And then when the models are contributed, they'll be in the open as well. Next slide, please. So right. So what we're doing is first creating the language, as I mentioned, and then we're creating a representative set of models, sort of a set of models from each contributing organization or vendor to sort of pressure test this language. And once we get that done, organizations are going to contribute models for sort of down selections, what we call that, and then there's going to be a process for publishing these models. Next slide, please. The status, okay. We've been having weekly technical meetings, and we've had 4 face-to-face meetings over the year. I believe 4, if I can count right. And there's a pretty good set of models that's being used to pressure test. And at the last face-to-face meeting, as Ari mentioned, that was in Shista, we approved a version of the language to proceed with contributions. So we've said, now the language is stable, and we're going to go forward with the next phase of the process. And we've set up an area for contributions to be uploaded called the playground. And we're also setting up, as I mentioned, some CI and some more formal contribution areas. Next slide, please. The outcomes of this, really one good outcome is we've all agreed to publish our license models into the open source license, the BSD3 clause license, which is a very permissive license. As I mentioned, there's a lot of work that they've done in tools and translations already. We have some SDF models for DOT, which is Zigbee Alliance, lighting and energy we're working on. We have some SDF models for OCF appliances in progress. And OCF, since they're sort of using Swagger as an underlying language, they see this as an alternative to having developers use Swagger. This is an easier entry point for developers, pardon me, to come in and create and maintain models. And they're working on a similar thing as with Lightweight M2M, some automatic mapping between OCF and 1DM. Next slide, please. So what we're working on practical IoT semantics. What we mean is what are the things we need to look at first to get things hooked up in a way that they're interoperable? And so we're addressing, we know we need to look at the affordances of devices. We also need to look at their behaviors and the context of, but we're really starting with the scope focusing on affordances. First, because we have device vendors involved, and then also that's really where we need to try to normalize first, because that's where a lot of divergence is today, where people are doing things in a similar way, but different enough to not be quite interoperable. Next slide, please. So here's our meta model. I don't want to spend too much time on it, but to point out that what we're using is a fundamental concept of affordances in 3 categories: events, actions, and properties. And then we're also defining data types as a semantic category that's reusable semantically across the different affordance categories. We have a thing called an object that we use to group categories into cooperative functional units, like to do things like on-off control and light dimming control and door locking and unlocking and things like that. And then we have some higher level compositional concepts, like a thing that can be just filled as almost any bag of any of the other things together, including other things. And then we have a view that we use for virtualization of affordances. So you can have views that multiple views that have the same affordance, but presented somewhat differently or in different with different constraints. Next slide, please. So a quick design overview. There's a much deeper set of slides. This is just a sort of skipping through this presentation, but I want to point out that this is a JSON-based language. We sort of wanted to create a domain language, but sort of based on JSON, and use JSON schema validation and things like that on the very front end. But we also wanted to be convertible to back end. So here's an example of a definition with 3 affordances. Next slide, please. And yeah, if you can see that, it's a bit of an eye chart, but basically there's an information part that says here's where it came from in its version, and the stuff that people like to keep track of. Then some namespaces so that we can sort of partition the different submissions and contributions and sort of combine them in some more controlled ways. And then there's some definitions of these different classes of object, property, and actions here. And there's some keywords that say what you're defining, and then there's some terms that you're defining, and we're defining switch and value and on and off. Next slide, please. Next steps for 1DM, we're updating the language. We're adding more features to the language. We're working on some of this model convergence across vendors and SDOs. We think it's going to be fairly easy to build some simple limited models that we can all share, and then work toward getting a common thermostat and a common light bulb. We basically want to start with demonstrating, though, some immediate value based on doing this translation and building some gateways and some ways of creating a layer of interoperability before we build the interoperability right into all of the endpoints. A little bit more about that coming up. And Ari alluded, we're calling it the semantic proxy. Well, next slide, we've got a couple slides about that. So the idea is that we use W3C thing description as a way to associate the metadata, the meta affordances, these high-level abstract descriptions with concrete protocol bindings. And that's really what the W3C thing description was designed to do, was create descriptions of instances of things that have high-level abstract affordances and concrete protocol bindings of different flavors. So we want to use basically 2 of these, one for each flavor of protocol, one from the thing we're consuming and translating from, if you will, and the other we're exposing and translating to. And obviously you could have a duplex version of this, but this is the basic pattern. There's already a couple of pieces of software that can do the semantic proxy part and know how to interpret W3C thing descriptions. So we think this is going to be a fairly easy thing to start prototyping in our hackathons and some of the other code programming and demo activities. Next slide, please. The way we feed it is by taking some SDF definition and converting it into, well, I say RDF here, but really all we need are URIs for annotation. But if we have RDF, then we can have a graph that backs the annotation. We don't have to build the graph right into the endpoints. You have a graph that's described in the model through these relationships between these affordances and things and views and what have you. And then you have applications that consume things and they interoperate at the level of the affordances. So once I know I'm talking to a light bulb, I know how to dim it. Next slide, please. Yeah. So the other thing we're working on, I've been working on for really a number of years now, and we really kind of kicked it off at the first Wishy workshop. So that's how long we've been working on this as well. And we made a lot of progress getting some trial formats put together in the beginning. And well, I'm going to go through sort of where we started and where we are and where we're going to go from here, because there's a lot of overlap with what we're doing in one data model as well. So next slide, please. Yeah, so we started off to create an extension to schema.org that would add IoT semantics to schema.org. And without going into too much detail, schema.org is a way of using basically RDF statements to annotate web pages. And the RDF statements are from a model that's pretty well constrained, so it doesn't really take a lot of reasoning to interpret what's in the web pages in terms of semantic annotation, but it was originally created for search engine optimization and has kind of grown into a thing that's starting to drive APIs and drive interactions with web pages more and more. So what we wanted to work with the relevant vendors and SDOs, sounds familiar, to architect a common information model for IoT. So it's coming at the same problem from a little bit different perspective. We were focusing on a process to enable free contribution from diverse organizations to really have a low bar and very permissive open source royalty-free licensing and drive toward normalization to a common model. So really, again, a lot in common. We wanted the domain and subject experts to be able to work with the tooling and not have to become experts in the semantic web in order to create models. And we wanted to work on practical integration with schema.org so that existing tooling and that can be easily adapted and extended to work with IoT stuff. So next slide, please. So our status, where we've come to is, we have a common meta model, which really we feel is already adopted in the industry. In other words, we didn't have to go evangelize a new way of modeling things because we looked at what people were doing. And these categories are really pretty common across all the different organizations. And again, it comes down to events, actions, and properties. And, we could have a lot of discussions about how these are similar to other ways of describing similar things and how they're different, but essentially we found a lot of commonality even in how these were interpreted between the different organizations and vendors and people who were already doing some modeling. So the other thing we wanted to do in schema.org though is connect them to these other ontologies, if you will, vocabularies such as the Genevi VSS schema work and BRIC schema that are being done in W3C, and also the SOSA and SSN. So since we have an RDF base, we can build graphs that include other concepts and other types of descriptive linkages. So we published a set of strawman definitions on a prototype website. That's at the domain iotschema.org, all one word. And we've published some definitions from some common IoT capabilities, and we've been using them in the W3C Web of Things and in the Wishy work, in the hands-on plug fests and in some of the examples and evaluations. Right, so next slide, please. The meta model for the IoT schema extensions is very similar to what you're going to see in Web of Things meta model, as well as what we built in 1DM. There's basically some interaction patterns that are events, actions, and properties. What we've done in IoT schema is wrap them up in a very similar functional element to what we were calling an object in 1DM. This is what we call the capability. And the capability is basically something like I can turn a light on and off. So here's an on-off state property that represents a state, whether it's on or off. Here's an action for turning the light on and an action for turning it off. And maybe some events having to do with, you know, the state changing or something of that nature. And then there are data schemas that describe, you know, how the data items look and what the constraints are. Not so much the on-the-air package schema, like a schema on the air, but more like this action has two parameters. One is the target brightness and one is the transition time, and they're both numbers. And then we allow levels of constraint on top of that, the range of the number, the step value of the number, whether it's an integer or a fractional number, floating point or fixed point, etc. So we want to be flexible with data schemas to say be either able to constrain a thing to having to be an integer in the definition itself, or to allow that to be defined in an adaptation layer and a protocol binding is what we call them. And so we'll see more about protocol bindings with the Web of Things work that Mukul will be presenting right after this. So the new concept we're adding here, though, is a linkage to a thing called feature of interest, which is really already a common concept from the O&M ontology on which SSN and SOSA and a lot of these other more recent works are derived from. And feature of interest basically, in my reading, comes down to mostly things that are either a location or some kind of equipment, some kind of physical sort of piece of something that you want to describe. And of course, there are features of interest can be properties of those things, and they can be much broader than that. But for describing what they do, they kind of describe, you know, the connected world nouns, if you will, places and things. But things like doors, not things like door locks, right? And so the door lock, once you combine the door lock, which is a thing we provide interaction patterns for, like lock, unlock, and determine lock state and send events about things being unlocked. Those patterns, once we combine the idea of a door lock with the feature of interest being a door, then we have a way of saying lock the door, unlock the door, and we start getting closer to a real world interaction pattern as opposed to having to think about a device that's responding to an app on your smartphone. And that's really what we want to get to with the semantics, is something that's both more interoperable, but also more connected to the real world, right? Next slide, please. That's enough on that. So our test cases, we've integrated these definitions with WOT thing descriptions, Web of Thing descriptions, and there's some semantic annotations. There may or may not be an example here in the slides. I'm not sure. I wish I put numbers on them. You know, these, I think we've been using these definitions of things like switches and light dimming and motion sensing, and it's turned out to work out pretty well, but it's been mostly a manual exercise. We've done a little bit of discovery, but we haven't really done a whole lot of automation yet. Some other organizations are using this in the Web of Things stuff as well to talk about their devices and protocols. I'd say we might have about 50% of the participants, you know, like using IoT schema or more. And there's some interesting Node-RED applications that we've developed, that have been developed. I'd say but mostly been by Siemens, by Darko, and Aparna, that have developed these thing description-based Node-RED applications that are really easy to use and kind of plug and play. And we really want to work on discovery next as sort of a thing that we're looking at in terms of interacting with the and intersecting with the W3C Web of Things work. Right. Next slide, please. So again, IoT schema for Node-RED. There's a GitHub project that you can go look at and play with, but basically we've we put IoT schema into Node-RED such that you can do semantic connections between things. And there are essentially, from a practical sense, you can connect events, actions, and properties with things that trigger them and things that observe them of your own code. And you can bring in some nodes that do automatic adaptation of units and ranges and measures and things like that, quantities and units. Right. Next slide, please. So the schema.org integration, what we found is that there's a little bit of an impedance mismatch, and first in the class names that we're doing, we're naming things that are similar to things that are already named, so we probably need to invent a bunch of new names, and also we have a lot of different property types. If you think about it, if you think about properties as being events, actions, property types in the terms of RDF relations, as being events, actions, properties, capabilities, data types, and things, you don't have that many. But if you think about them as being temperature and humidity and acceleration and voltage and all these other things that you can do in controls, it quickly becomes hundreds or thousands. So what we're looking for is a way that we can do some layered connection to schema.org so that a schema.org application can discover that it has some basic things that it can do, but then it might need to have some extra awareness in order to know how to actually do some of these things and manipulate these. It'll need to be able to go to another level. Just like if you wanted web software using schema.org today to understand which venue you're talking about, and the basic pattern is there, but then you still need software that's able to show different arrangements of seats in your stadium, etc. The same thing with IoT. You'll need software that'll deal with different types of cameras, for example, and doesn't have to assume all cameras are the same, because you have some annotation like thing description to tell you what affordances are there and what you can do and what you can't. Right, so next slide, please. Okay, so we started the community group for the IoT schema. We have a few members, but we haven't really ramped it up yet, because the purpose of the group is to have an IPR venue, if you will, for accepting contributions. So what we're hoping to do is sort of combine this with the one data model work, so that we can use one data model as a front end for entering schemas, and then we're hoping that we can all use BSD3 clause and run the community group as a way to accept contributions and publish things on the IoT schema side. So one data model will have its process of down selecting things, and then we'll have another process of accepting those or other types of definitions into IoT schema for publication there. Right? Next slide, please. We're getting close here. So, right. This is really just more of the same. We're aligned with the meta model. We expect to be able to use the one data model language and tools to provide this developer-friendly front end, so we don't have to duplicate that work. But we need to work on converting from one data model to RDF. And one example that was really interesting in my exercise of doing some strawman conversions was that in RDF, enum values are URIs. They don't have to be integer or string or booleans or anything like that. They can be bound to different, you can have, for example, a light control that uses a true-false boolean. It can use the text phrases on and off in English, or it can use, say, 0 and 1 integers to represent true and false. And those can all be described by the same URI enum, but they can't be described by the same JSON schema enum. So we're thinking about how to deal with conversions there. And there are a couple of issues like that become interesting. Right, next slide. I think we're getting... Yeah, so going forward, we're going to create an experimental area for people to sort of host these definitions and test the hosting of them on schema.org. We already have them on our own experimental site. Create namespaces, have some kind of CI process, and then have a way so that when someone uploads definitions, they can immediately dereference them in their own namespace and not have to wait until things have been argued about and accepted, so that we have some ways that get some traction immediately on. That seems to be the biggest barrier to people using semantics, is you really need them to be sort of globally referenceable, or at least referenceable within the scope of all of your experiments, which for IoT is pretty broad. So to have a place to upload them and then reference them online is pretty useful and valuable. So we want to try to provide that early on. Right, next slide, please. So here's some URIs for the one data model work and some semantic proxy proposal. And on the next slide, there are some resources for some of the other stuff that I talked about. So with that, I think we have a few minutes for questions, comments.
Well, one question that came up in the Jabber room was, how do you actually use these model files? So is this something like a MUD self-description you would attach to a device? So when a device is integrated into a system, the system starts to read that model? How are these one data models being used?
So they're being used and will be used as semantic annotation for a thing description. So in that sense, yes, it is. They're attached to a description of a concrete thing, an instance of a thing that has network addresses and security protocols and things like that. And they're basically used to orchestrate the connection of an application to a connected thing, and it's understanding how to use the connected thing. So in that sense, it's a sort of complementary to something like a MUD file that kind of describes for a different actor in the system what to expect from a thing. A MUD file describes to a network actor what kind of behavior to expect. This describes to an application that wants to use the thing what kind of affordances and again, it's through common terminology that it does that. So it needs to have an understanding of the meaning based on terminology. And so in that sense, it's also similar to the MUD files. There's a schema for a set of terms and a set of concepts that are used to talk about what this device has, is, and does.
Yeah, so if I can comment on this, we discussed this at the workshop last time, and I think one way to think about it is an SDF file, it's kind of like a class definition for a set of products, like our product line. A TD file is a description of an instance of a device. So it has all that, the modeling stuff, plus things like IDs and protocol bindings like URLs and whatever for a particular device. I think MUD describes kind of the system network configuration. So it's like how the routers are configured for both security and quality of service and so forth. I do think one missing piece here is how do you configure orchestration? How do you configure the system? How do you set networks of devices to do a certain task? And that's something that we probably need to think about a bit more. But one thing we've been looking at in TVs, for example, is using links for that. But maybe that's kind of an indirect way to do it. Maybe we need a more direct way to do metadata for systems.
Hi, this is Eve Schuler from Intel. Thanks for the presentation. It's great to see how far you guys have come in the last year, or since the last time you spoke about this. Similar to some of the other questions, it would be really great to see an example of how things come online and how it maps to the various parts of the architecture, and when things get called. So really grounding it in an example where these different pieces get pulled in, that would be really great to see in an upcoming talk. The other thought I had was, are you thinking about that in these namespaces where people define their affordances, that there's room for the evolution of them? Is there that kind of flexibility because things just continue to change over time?
Oh, that's a topic. Because really what we're discovering is that the normal mode of things is going to be, evolving and not so much static, especially just for the next sort of whatever time period. So there's been a lot of discussion about how to enable innovation and things to evolve and not sort of keep them fixed while having interoperability and not breaking interoperability. And so some of the versioning discussion covers that, and just some of the basic, how do we build and partition models? We make the pieces small enough so that if one piece needs to change a lot, it can be substituted with a different piece. And we're really just learning about that. So that's really one of the ongoing topics, I think.
Oh, so I think I'll amend what I just suggested earlier, which is I'd love to see an example sort of from beginning to end how somebody using these components would actually tie in with them, just grounding it in a use case. I would even go further to say, and then what happens when things get changed? Let's include that part of the example as well. But anyway, enough for now, but thanks very much. That was great.
Thank you.
This is Elliot. Eve, stay tuned. This is a pretty big topic, actually, that you just hit on. It's actually a really good one. We have a lot. This is the IETF, right? We like building blocks, and actually, so do other SDOs. Building blocks are nice and easy to build, right? So the question is, how do you put them together? Right. This is a topic that I'm about to delve into in just a few minutes, so I just want to say stay tuned.
Great, thank you, Michael. Thank you, everyone. I think absolutely this is a topic we should have a closer look. We're gonna start on the last slot for today, and we should definitely continue on the upcoming activities. In particular, the upcoming Wishy calls is something where we could take deep dives on this. So anyone interested in topic of this and at IoT data model and interoperability at large, very welcome to join the Wishy calls. Okay, but now we need to move on. We have one more update from a W3C Web of Things coming, and then we'll have the final discussion that Elliot was already referring to. Thanks a lot, Michael. Okay, so Michael McCool, please go ahead.
Okay, you guys can hear me okay?
Yes.
Okay, so these slides look familiar to some people who are the last IETF. So I'm actually updating a slide deck that was done before, and I've highlighted the changes. So basically, Web of Things is progressing, and I'll give an update on the status. The next steps parts relate to our new charter and items that we're going to be working on over the next 2 years. And in particular, there's some items of high relevance to this discussion, including discovery and interoperability. So anyways, like any standards organization, we're looking at enhancing interoperability. And we actually have two working groups in W3C. The interest group basically does research and pre-standards work, drafts and so forth, and also validation. And that was renewed for another couple of years in October. And the working group just finished their last charter. We just delivered our candidate recommendations that should go to PR by the end of the year. And we have a draft that's been submitted and is in process right now being voted on for a new set of work items and deliverables over the next 2 years. And I'll discuss that at the end of this talk after giving an update of where we are. So I'm going to go pretty quickly through the background and the current status, assuming people have seen some of this before, so we have more time to spend on the new items. Next slide. Right, so the basic deliverables of the last charter were the things you see listed here: thing descriptions, security guidelines, scripting API, and binding templates. So the main deliverable here is the thing description, which has already been mentioned. And basically, this is the metadata format that describes the interaction model or affordances of the devices. This interaction model is actually closely aligned with IoTschema.org and actually SDF. So we have a similar set of interactions, and it is our intention to remain aligned, and in fact, to improve our alignment, make sure our vocabulary is consistent. TDs generally are also a place to use annotations that are generated by higher level models. So as I mentioned before, the way to think of SDF is a class definition that defines vocabulary and the high level models. And the TD is a description of the actual instance of the device, which includes all that, but also includes things like here's the URL you have to talk to get this property. Here's the security bindings. Here's the location of the device. Here's the ID of the device, and so forth. So a particular device. Now, there's also, I mentioned protocol bindings. The purpose of that is to say, okay, there's this high-level interaction model. I can read and write a property, for example. How does that map down to a specific protocol like CoAP? What are the URLs? Are there any header options, and so forth? So we are also have a document we published, the binding templates, which basically describe informatively how you would map for a particular protocol, a particular abstraction. The scripting API, we actually decided not to publish this in a normative document because we're still discussing the deployment model for it. Because the scripting API enables essentially, computing and rules engines and this sort of thing. And so it depends a lot on the deployment model of what it actually looks like. We do have a strong draft, and we do have an implementation that's open source, and we have used it for many projects, and it is quite convenient. We're just need to work on the landing zone for it a bit more. So next slide, just a summary of the status of these. So we have informative documents, the notes, and we have rec tracks or normative documents. I didn't mention the architecture, but the architecture is kind of like just describes the whole system and how the pieces fit together. So we are taking kind of building blocks approach. The architecture describes, how the building blocks fit together, and we have more building blocks in the pipe, like discovery, as I'll mention in a minute. Okay, next slide. So yeah, just a bit more detail on this. So the what architecture document describes constraints about what kinds of devices and protocols make sense in the context of a web of things. So particular web of things definitely goes beyond HTTP, and it arguably goes beyond RESTful interfaces. So we're looking at targeting pub/sub type things like HTTP, and we're currently looking at OPC UA and things like this. But the idea, though, is it maps these protocols down to an abstract set of affordances. And the way to think about these affordances is an affordance is like, what do you want to do? Open the door. And a protocol binding is, how do you do that? What URLs do I send what messages to, etc. What verbs do I use? So you can see a thing description example over here, and it's just a JSON file that describes various things. Now, I actually want to say it's actually more specifically, it can be interpreted as a JSON LD 1.1 file. And JSON LD 1.1 has the advantage that you can import it into an RDF database and manipulate it with RDF things. However, we were careful to avoid a dependency on RDF. So not everyone wants to deal with RDF, and we didn't want to create the expectation you have to understand RDF to use thing descriptions. So you can treat it like a regular JSON file, and that's totally fine. There's many use cases that just do that. However, the at context there describes the version and the vocabulary that's used in this, and it also allows us to pull in extensions. So for example, if you want to use vocabulary defined by IoTschema.org, you could define that IoT vocabulary and start using terms from it like IoT Lite. If you wanted to use a vocabulary defined by an SDF file, one approach we're looking at is compiling SDF down to RDF and then importing the vocabulary just like you would do here for IoTschema.org. So that's how you connect these two together. And then if you then imported the thing description into a database, you'd be able to interpret all the information from both SDF and the instance definition. Next slide. Right, so then the notes. We have actually a pretty big document on security and privacy. It's guidelines only. There's also a best practices document, which is more aimed at what you actually need to do to build something that's reasonable. One thing worth saying is thing descriptions are descriptive. So they describe what's out there, including brownfield devices. But there are brownfield devices that don't do a very good job with security. So to describe those things, you have to have a descriptive power to describe things that don't have good security. We also want to encourage people to do good security. So we have a best practices document as well that describes what you should be doing. And one thing we're actually looking at in our next round is profiles that are a bit more normative about what you should be doing. Anyways, the scripting API, as I mentioned, is we're talking about various landing zones for that now. Next slide. Right. So mentioned just in LD 1.1, we also have a stream looking at various security protocols, and we're looking at expanding that. But you can add new security protocols with the semantic extension mechanism. And yes, and we currently mostly look at HTTP and CoAP, and we're now and MQTT I think is partly supported. We're working on more of that, and we're looking at further things like OpenCU in the future. Okay, next slide. Okay, so here's what I want to kind of spend at least 5 minutes of my talk discussing. So this is our next 2 years, and we got a bunch of things we want to work on. Now, the most important things here are probably the interoperability profiles, which has its own normative deliverable, discovery, which has a normative deliverable, and then things like the protocol vocabulary bindings. So we're going to be doing a lot of work just extending things to new protocols like OpenCUA and obviously and fixing up MQTT and so forth. We're also under profiles. One of the issues is that thing descriptions are open. They can describe lots of things, including things in the future that might appear, right? The trouble is, if you want to implement a system and say it's compatible with WebOfThings device, or go to a store and buy a WebOfThings device and bring it home and have it work, right? You need to have a more finite set of requirements for what does it mean to implement something that can read any WebOfThings device or talk to it. And so the idea of profiles is we would have a finitely implementable subset, so have a profile that says you only have to support these 3 protocols or whatever. And so we are working on this core profile that sort of is, the minimum requirements for something that if you satisfy this core profile, it will interoperate out of the box. So under discovery, we are basically, we had a document we worked on in the hackathon that you can look at, but it's still very early. But at a high level, I want to say we would like to really avoid reinventing the wheel here. So it's very, very important that, and we have the full intention of working closely with IETF, with looking at existing standards. But I do want to say at a high level, the architecture we're looking at is to divide this into 2 phases. And actually, before I say that, I want to say we're actually looking at both local and global. So by discovery, I don't mean broadcast something on the local network and get pings back, that kind of thing. Don't assume that. By discover, I mean, how do you get access to the TD metadata? Like, how do you find it? And that could be a global problem, like on the internet. If you're looking at like a smart city and you want to find services to handle traffic, it might be local in your home network. Finding the lights and the light switches. So we want to handle both those contexts in a consistent way. And we also want to highly emphasize privacy and security. So we want to have a privacy-preserving architecture. So the general strategy we're looking at is to divide the problem into 2 parts: introductions and exploration. Introductions would be first contact protocols, which basically is what's the very first thing you do when you're in an unknown network. And then exploration is finding and getting access to detailed metadata about the available services. And between those 2, you have to have an authentication process so that you're only giving out that detailed metadata to people who have authorization to it and the right to use it. And so the idea is the introduction protocol should be privacy preserving, should be open, but giving away as little as possible. And in fact, what we want to do is just have introductions point at a directory service. The directory service then requires authentication and authorization with the appropriate access controls, and then you can do the search. This also prevents things like denial of service attacks because, maybe metadata searches could be expensive. So that's the general protocol, but we have many candidates for both introductions and for directories. We also have many different ways in which you could do queries. from simple keyword search or location-based search to full semantic, Sparkle endpoint semantic queries. And you won't necessarily implement all of those in all possible devices. So we, however, have 2 years to discuss this, and we are currently in the process of gathering requirements and understanding use cases and surveying the landscape and figuring out what makes sense. We did do, a deep dive onto core resource directory. It's certainly one of the candidates for things we're looking at for like directory services. Likewise for introductions, things like DNS, DHCP, things like that are also quite reasonable introductory mechanisms. I also feel there'll be more than one way to do this, especially for introductions. Many different styles of introductions could point to the same directory service, and that's totally fine. Different contexts may require different mechanisms for first contact. For identifier management, there's a group in W3C that is looking at the whole process of decentralized identifiers. And this is also an issue that is closely related to privacy. How do you deal with mutable identifiers, temporary identifiers, non-global identifiers, locally scoped identifiers, this sort of thing. And actually, what if you want to change the identifier on a device to like break tracking? How does that happen? How do you notify people of updates? Not mentioned here actually is onboarding, which we're looking at. But I would say the primary focus in the past has been during operational phase. I think when we look at discovery, obviously we're looking at discovery phase. One of the first things you want to do when you onboard a device is you got to discover the places you can onboard to. So I think they're closely related. And obviously to do access controls, you need to have keys and so forth being provisioned. So we're going to be looking again at the lifecycle and probably touching at least on the onboarding process. And again, there's a whole set of standards we figure out to be consistent with. Right, and I guess one last final thing is link relation types. So the thing description has a section, it's not an example, that can link to various other resources. It could have various resources, like maybe the TD points at an SDF file to say that the TD is an instance of that class of devices, or it has these capabilities. It could also be, as part of orchestration, a light switch might be associated with a light, and you might have a link for that. But we don't have any standard link relation types. And of course, there's a set of link relation types in INA, but there is a huge number, and it's not clear what's used for which purpose. So we want to be able to clarify that and define what relations to use for what purpose. And complex interactions, finally, that's one more thing. We're looking at, currently you can use thing descriptions for like hypermedia-like controls, but it's not obvious. It's not obvious what happens when you post a new resource on a device. Does it change the thing description, or does it just appear as a new thing description that is dynamically generated? So we want to clarify that by providing basically guidance and examples for complex hypermedia-driven controls. Okay, well, I think I went over time, but maybe we can have if the chair's one, I can have some questions.
Okay, thank you, Michael. Any quick questions, comments, reactions on this? So here on the T2TRG side, of course, we've been doing a long time, basically all the time, close collaboration with the Web of Things, and we'll be continuing doing that. We have a lot of common interest when it comes to the interoperability on the data, on the hypermedia, on security, etc. And we are kind of looking at the more researchy aspects here on the RG side, and then seeing where it makes sense to do standardization on W3C, IETF side, etc. That's how has been our pretty much mode of operation, and I plan to continue working that way also when the Web of Things is being rechartered. And you can see having us common activities on the hackathons and on wishicles, etc.
Yeah, I think in general, we are highly motivated to keep things converged here and to collaborate with people and making sure we avoid any, silly, unnecessary differences between things and to have things very nicely.
Hi, Michael. This is Eve.
Yes.
Can you comment on? I know there's a lot of discussion about kind of IoT-centric convergence of things, all the different SDOs that are focusing specifically on IoT, but there's a lot of work inside of the IETF that could benefit from discussions around directory services. And so can you share some of what you're thinking about DNS and the resource directory, how that sort of aligns or not?
Right. So I think a lot of the existing directory services, let's say, provide an index of links, and the thing descriptions provide more complex, graphs of metadata. And so I think that a lot of the existing services, have like basically tagged links. And so I think we need to expand upon that. There's actually a thing called a data hub in the core that gives you access to more data. And something we're looking at is combining resource directory, which is a set of links, to that. One thing we want to avoid doing generally, though, is just broadcasting metadata like this is an insulin pump, because I wouldn't want necessarily everyone to know that I have an insulin pump. So I think that we need to think about what kind of relation types we want to support in public directories versus private directories behind authentication. But we are looking at DNSSD, DNSSRV. We're looking at DHCP. We're looking at Core RD. But a lot of those really are best at linking to places where more detailed metadata can be provided. As far as directories, we have prototyped directory services that can do things like semantic query. A relevant standard there is Sparkle, which allows you to do federated graph searches. That's quite expensive, though, and we think that's only for the most advanced use cases. I think there's lots of other ways to do queries that directories could support: keyword search, template-based search, and so forth. One thing we are looking at for introductions are location-based search, because I really want to know, the set of services available in a certain area, and that's one thing that we're discussing around DNS right now. Okay, I see a question on the floor.
Yeah, hi, this is Elliot again, Mike. Reacting a little bit to what you said and also to what Eve said, there's a ripeness issue here for some changes into the overall internet architecture, as I see it. And we've started it sort of slowly in different places. One of the places that work is being done, and I think is interesting work, and you'll laugh perhaps, is in the DHCP working group. What they've done is they have taken DHCP parameters and created a Yang model for them. Now, Yang isn't usually the sort of stuff that W3C deals with, but the nice thing about Yang is that you can serialize it. You can serialize it in various ways. Once you can serialize it in a way like JSON or XML, however you want to serialize it, you can do other things with it too, like sign it, encrypt it. These are things that are useful if for privacy preserving technologies, for instance. Now, obviously, you can't do that with every last DHCP object that we have defined. If you're still in the IPv4 world, perhaps your IP address is not something that you're going to serialize in this way. Maybe, I don't know. It's worth thinking about. I know they've done a lot of work at categorizing some of these things the last couple of weeks. Now, that ties to the trust anchor discussion that I think we've been having quite a bit of. And we have other building blocks along those lines to leverage, one of which is EST, enrollment over secure transport, another of which is EAP, believe it or not. You can look at this in other contexts. The key point there is that if you want to gain parameters, if you want to exchange information about devices, right now we have a lot of challenges in establishing trust anchors. And so this is an area where the network infrastructure can play a role. It's up to and it also plays into another aspect that we're hearing a lot of in the industry, which is zero trust networking, the basis of which is you should declare yourself and allow for establishment of trust as a first-class component rather than trust being assumed.
Okay.
And so, I'm sorry. Mike, go on.
I'm trying to make a list of things to respond to. Maybe you can unpack and answer a few of the questions, and we can continue the discussion with further topics. Okay, so just about the Yang versus whatever. So one other work item that I want to get off the table is there's Yang, there's CBOR, there's JSON, there's XML. There's various ways to transmit data on the wire and to encode metadata. I would like to see it all interoperable and have a common data schema. And a lot of people use an extension of JSON schema or various different extensions of JSON schema. I love to see that cleaned up so we have one way to declare data models for any serialization. And things like Yang is just a choice of serialization of our information model. And we still have the information model. So we want to export things in JSON, that's totally fine. I think, a lot of MUD stuff is done around Yang. I would like to see that not really matter so much as it's just a structured information that's available. Regarding trust anchors, I completely agree. I think that, we need to think less about onboarding to a system and onboarding and thinking about, establishing trust. What is the way we establish trust between devices? And so privacy is a lot about who do you trust, and we need to figure out ways to make that happen, right? Okay.
Maybe I'll stop there because this is a pretty broad topic, and it actually leads into the next topic.
Absolutely.
Yeah, well, go ahead.
Yeah, so exactly, I had the same thing in mind. So I think this links very nicely to our next topic that we've seen. So Michael, did you have any final conclusions you want to share before we move on to the next slot?
No, I just want to say that we had a discussion about MUDs, and I think I want to get that aligned at some point too. Be all on the same page with MUDs and TDs as well. Okay.
Absolutely. I think that we should take that, for example, one of the upcoming Wishy calls, take a stab at that topic and see how we can find some more convergence, common tools, common ways to get more interoperability. I think that will be a very interesting topic. Let's take a note of that.
Okay.
Okay. Thank you, McCool. And then off to our final topic. You saw something along these lines on the agenda. It's related to these discussions that we have had over the past few months or so, and now we're basically talking about all of these different activities that we have around going on IoT. How should we perhaps have, where's the right fora have this? What is the right structure and groups? Should we have more side meetings, intergroup, new working group? How really go forward on this discussion? Have been a lot of discussions over the week, and IoT Directorate, etc. But now this is discussing at large with the IETF and IRTF community. And Elliot kindly volunteered to take a lead on this discussion.
Okay, thanks, Ari. Okay, so I'm Elliot. I represent only myself in this discussion. I'm not trying to represent any ISG view or any other view. I'm not a member of the ISG. I'm not a chair, blah, blah, blah. However, I have been convening some side meetings, and in one of those side meetings, we had an area director show up, and we've had some discussion on lists about a perennial topic at the IETF, which is how do we organize around IoT. So this discussion is about that. As nobody in this room will be surprised, we have a huge amount of work going on in IoT, not only in this organization, but elsewhere. So, of course, we have this group. I'm sure that these two gentlemen would say that I mischaracterized the work in some way in terms of T2TRG. It's a very broad activity, which is great, by the way. It's fun to participate here. And I particularly enjoyed participating in the workshop on last Friday. We have the IoT Directorate, which the IESG members have, in particular, Ignis described as a reactive component of our system to provide review of work that goes on at the IETF. We have a great many working groups that tackle issues that affect IoT. Sometimes it's a direct intention to go into IoT. Sometimes it gets backed into. An example of an area where I think really IoT got backed into, particularly onboarding, was Anima. I'm sure they didn't start out thinking that there were going to be an IoT onboarding discussion, but that's where they ended up. And then, of course, there are the plethora of SDOs that are involved in this space. As Eve mentioned, there are a great many building blocks all around which we have, I think, perhaps a lack of guidance at this point. That is something that Ignis pointed out in his discussions on Monday. So he proposed something. And I'm going to do his proposal some injustice, I'm sure, and for that I apologize to him. But the IESG did have a meeting in which they discussed alternate methods to organize around work. The classic method that we have in the IETF is to have a working group. But working groups usually have deliverables, and they're usually tightly constrained to very specific charters to accomplish those objectives. This would be a little different. This would be more of a standing group that would focus on a broader topic for slightly different purposes. One of which is and perhaps the most important of which is to focus on how we put all these different building blocks together. How do we make them a useful system? So the idea would be, okay, great, we have core over here, we have CoAP over here, we have COSE over here, there's the Web of Things, there's IEEE 802.1 AR, there's 6TISH, there's other IEEE groups, there's ODVA and SIP, and the next generation of SIP that is coming along in the industrial space. I can mention a zillion of these things and spend the entire time doing so. But putting them together as a system is something that we could spend some time doing. And the key here, I think, is that it can't be proprietary to IETF work. Other people are doing work, and other people are doing really good work. But we could also do a couple of other things. So what does that lead to? It means maybe we're delivering some informational documents in the form of architectures. I have to say the IESG in past has not been in favor of doing architectural documents, but here I think they feel differently. But that could be me projecting a little bit, and Ignis could say more if he were here. But I think this is, people who are in the room on Monday, please correct me if you think I'm wrong. We could certainly spot some gaps and overlaps. I think, at least my feel at the moment, is that there are both. An example of an overlap is the plethora of onboarding mechanisms that are developing at different levels. An example of a gap would be some amount of authorization models that tie the network level onboarding into the application space. A good example of that is the discussion that we just had. I think Mike just mentioned about how we do authorization of resource directories, for instance, and how you bind all the way through from an onboarding perspective, which was Eve's point in terms of showing the whole flow. Okay, so this was one approach, but the people, at least on Monday, did not really take warm to it. I think there were a couple of issues that were raised, one of which was that this was an excessively broad area, and the IETF has let's just say a sketchy track record for handling such a broad area, and it was a little vague. And the work that we could clearly see before us related to network level onboarding, more of that was the rest of it was a little fuzzy. But so one approach that we could do is we could go into onboarding. So let me talk a little bit about what we did in onboarding this week, and that can give you a feel for alternatives even to having a working group. So the IETF, you have a working group. If you're lucky, you meet for an hour or two during a week where you've flown a great distance to be here. We met, the onboarding group that we had side meetings that met 3 times this week. People essentially sacrificing sleep time, especially after the social, to come join us. And we actually had a very particular problem that we were focused on, which is the plethora of approaches. And the way I put it is that if we can get some consolidation of approaches, maybe we can get some acceleration of implementation. So we were talking a lot about the gazintas and gazoutas of this process. For those people who are not familiar with that phrase, and there were some in the previous session that I have Gazintas meaning inputs into the process of the network process of onboarding, and the gazoutas meaning what you get out of that process. An example of which being DPP, which I'll discuss in a second. And then we wanted to go through a great many use cases to see if we could validate against a very small against one particular architecture. So fewest possible inputs, fewest possible outputs, common components where possible. Common components also means that probably we need and consolidation means that people need to be able to take ideas off the table. And that's hard, especially when there are a lot of vendors involved. The typical way that happens is somebody says, we have too many ideas, we need to take some off the table, you take yours off the table. Cisco and I and a couple of others have been looking at Anima and bootstrapping remote key infrastructure. One of the things we've been looking at is whether we can take that one off the table in favor of other mechanisms. But that requires careful use case analysis, and we spent a fair amount of time this week talking about that. We spent a lot of time talking about DPP. This is Device Provisioning Protocol from the Wi-Fi Alliance. The common input here is a public-private key pair. This is a nice architectural component because it's quite common already. If we look at Intel's SDO, the Secure Device Onboard Mechanisms, one of the outputs of that mechanism is a public-private key pair, an EDCSA public-private key pair. Well, that can feed right into a network-level onboarding process here. Well, that's nice. That's something we observed. The same might be true with some of the OCF processes, but I'm not 100% clear on that. So that's an input. The input could come in the form of, say, that SDO output, or it could come in the form of a QR code, or it could come in the form of some other import mechanism. The output is something that is also as interesting, and it has a couple of architectural implications. The first of which is a question, which is who gets to decide what sort of authentication is used for network and what sort of authentication is needed. I think there are a fair number of networks out there that use private shared keys as a means to use wireless. Either that is in the form of SAE, or is it in the form of, it couldn't be in the form of just a PSK that is an input to another process. Or in DPP's case, they have this other concept of a connector. DPP, what it really delivers as the output is what Dan Harkins would call a profile. And the profile can contain these various options, including the potentially for a certificate. Another nice feature about DPP is that it has a label standard associated with it. That's something that we don't want to have too many of. Otherwise, the manufacturers will just throw up their hands and we'll be right back where we started from a fragmentation standpoint. And so that's one reason to take other mechanisms off the table, is that here we have a labeling standard. So we looked a little bit then at TEEP here at the IETF. And the nice linkage between DPP and TEEP is, so for those people who don't know, TEEP is an EAP method. It has some nice features in that it has TLVs to handle a PKCS7, PKCS10 transactions, so you can get certificates, you can reprovision certificates. Using TEEP, you do this at the L2 layer. You don't have to worry about your interface having been up. If you look at a lot of the onboarding mechanisms that have been defined in other fora, usually they're a bit higher layer. And so they assume, for instance, that you're able to communicate using HTTP or COAP, when in fact you might not even have been assigned an IP address because the network will not have authorized you yet for that purpose. So TEEP allows for lockstep authentication server driven authentication, meaning if you need a certificate, if the local deployment needs for you to have a certificate, you can say, I need you to have a certificate, please request one. So that's a nice feature. And it can say things like, I need you to reprovision a new certificate. And why would you do that? It's because perhaps, for instance, the trust anchor has changed and you want to roll the certificates onto a new trust anchor. Right? So there's some nice features for TEEP. Now the question is, how do you link DPP to TEEP? And we spent 3 days worth of time talking a lot about that. If the output of the DPP process is, for instance, a PSK, could you then link, for instance, that PSK using TLS PSK? The other side of this also is that we wanted to cover wired onboarding. We have been going back and forth quite a bit on that, and we haven't yet really landed on how that should work. But what that shows is that we have quite a number of calls still to have. I see that Ignas has walked into the room, so I'm going to give Ignas an opportunity to talk in a little while to say, and I'll just back up and review in a few moments on that. So we had a list of questions that I think we focused around on this, which was how do we re-provision, what to do for wired, what sort of credentials should be supported, and this is basically a review. So the next steps that we came out of today is that we know we need to write an architecture document. We know we need to sort wired. We have to handle manufacturer certs in this process because one of the things we want to be able to do is detect counterfeit gear. This is something that Brewski handles quite well. It's right in the wheelhouse of Brewski, in fact. How to link PSK output of DPP to the next step, if that's TEEP or something else. That's actually, it's not 100% nailed down, but it's close. And we think that the profile mechanism that DPP has will lead to that. There's also another mechanism that was defined in a draft called EAT-MEC, which looks like it can actually be further merged into TEEP. And so there's some nice things there. So what does this mean about an IoT working group? So in the Monday meeting, I think people were very interested in focusing on IoT onboarding. So is that a starting point? Or is that something that we should just create a working group on that just sort of zooms in on that topic? I think I heard from people in this room earlier that really we have other things to talk about beyond just the network level onboarding. There are a great many, this is a very large elephant, and there are a great many places to touch it. And so there are probably other aspects that we can develop. So maybe it is really a starting point. And authorization in the resource directory is another area I think that's worthwhile. And what I just mentioned previously at the microphone about how we authorize, how we provide secured information about the network and about the device in a way that each side knows who the other is for sharing information in a way that's more confidential than it is today. Is also something that we could explore in that aspect. But it also leads to overlap with this group, for instance, as to what's research, what is explanation of the existing capabilities, and how do we drive. And I think one of the things that Ignas said was it'd be useful to have a place where we could drive work into other groups, such as how do we take the output of the DHCP working group and use that, say, in a serialization. And so that would be a good topic for such a group, I think. And of course, this needs to track across SDOs. And the reason it needs to track across SDOs is because not all the good work is going on here, it's going on elsewhere. And we want to leverage that work in as much as we can. There are certain limitations in doing so. With that, before we have an open microphone discussion, I thought, Ignas, you might want to say a few additional words.
Ignas Bogdanas. Right. So apologies that I was not here at the very beginning of the session. I was not aware what you promised to the group that I will do.
I said you'd go ahead and create this thing, and there'd be no further discussion. It'd just pop up in the agenda next time. Isn't that
right? If maybe you want to put that slide that we discussed Monday morning at the side meeting just as a context, or did you go through that?
I went through some of. I didn't go through that exact slide, but I talked through it.
All right. So a very brief summary then of the thinking. There's a lot of activity of the individual work happening on the components that are relevant to the IoT in one or the other way. It doesn't appear to be the place that works on combining those components together. That's one. gathering the requirements and explaining to the external entities, be it SDOs or the user groups or in general users of these technologies. Third thing is, if we look from outside of the IETF, is it really evident that IETF works on IoT? It's evident that the IETF works on multiple components, but does it work on IoT systems or solutions as such? Whether it needs to work on that or not, it's still an open question, and to what level. So the working thinking about that is probably we need a structure which would work on coordination and merging of the individual working groups' outputs into something broader. And this would include mostly taking the requirements for broader scope work, slicing that into the pieces, directing that to the individual working groups and coordinating that work. Now, one specific work item that I hear a lot is about the IoT onboarding and the things related to that. So probably that's one of the specific focused working groups that needs to happen. And the feeling that I hear from a community that there is interest, there appear to be people who are willing to do that work. So probably it's simpler to answer. Now, the IoT coordination group, it's not so evident. I think those are the comments that I have. And
okay. Dave Taylor. So I have 4 comments on topics I've been trying to save up and not interrupt. And so let's see if I can keep them in my head, which have to do with this group, onboarding working group, website, and IoT directorate. Those are the 4 topics I'm trying to, so if I forget one, hopefully somebody can remember that. All right. So on the onboarding topic, I am all in favor of having a working group. The only concern that I would have that the working group charter or whatever would have to address, and this may have come up in your side meeting, I was obviously there in the Monday meeting, but not in the other ones, is that on your one slide that said something like too many solutions, market fragmented, can we consolidate? And of course, there's the classic XKCD 927, which comes up in that, and as long as you can convince the community that XKCD 927 won't apply, then I think the working group is a great idea to have something that's scoped to IoT onboarding. And for those of you who don't know, that's the one that says there's 14 competing standards, what do we do? Let's create a new one. Answer, there's 15 competing standards, right? So I'm all in favor of that. Thank you. Please continue. Hopefully you can do something and find a justification. That's topic 1 of 4. Okay. On external people, do they actually know that the IETF does IoT? This is the website topic. If you go to the www.ietf.org right now, you'll see topics of interest in the header at the top. One of those topics of interest is IoT. You scroll down to the bottom of the page, you see a great big thing there saying Internet of Things. And so hopefully anybody who actually goes to the website would never come away with an impression that we don't do IoT, because that's the whole point of there. And Greg has been running this thing about how do we improve the website, and so you have ideas of that. There's an initiative there that doesn't require a working group to improve that visibility. Thanks to Greg and anybody else involved in that, and please continue that. That's for the external visibility point. Let's see. This group. So some of the topics that you mentioned or some of the discussion from Monday that you were summarizing, giving an accurate summary of, was do we need a group that has perhaps no constrained charter and does more broad things, including gap analysis and coordination between SDOs? I think the thing-to-thing research group is doing a great job of that, especially because there's so many people in this room that are working group chairs and editors and documents. I think we have a great group for that. I don't know if we need to compete with this group, because if it ain't broke, don't fix it. I like what you're doing in this room. Please continue. And then my last topic, what did I say? Internet Area Directorate. Some of the other coordination, which is different categories. Another ones is the Internet Directorate does have some of that role too of doing stuff across working groups. That's the 4 things that I came up to say. I don't know if I'll have more given the rest of the mic line, so I'll go away now.
Just to clarify, you said IoT Directorate or Internet Area Directorate?
We have both. I was referring to the IoT Directorate, but yes, we have both that have different roles. But for the coordination across, say, working group chairs, because the IoT Directorate not only coordinates across SDOs like this group does, but the chairs come together and report out all that they know about what other working groups are doing on a more regular basis. And so those calls are what, monthly, bi-weekly, something like that. That we have calls where we report out, this is what OCF is doing, this is what OMA is doing, and so on. So some of that is going on right now within the directorate of sharing information across SDOs, but that's primarily between the working group chairs. This group, Thing-to-Thing research group, is the one that does it across the global community.
Just a quick comment. Let me put, for a while, my IoT directorate chair hat on. So, yeah, what Dave said, we have this coordination across the groups. And maybe what we have had so far in the directorate is that those calls have been closed. It's only for the directorate members. Maybe one thing what we could do here is have that alignment reporting calls open for everyone. That could be one way to go forward, since we already have this activity of reporting. On the frequency of those calls, it's basically once before the IETF, usually after the deadline before the IETF, we have had this one call where we go through all the groups and get, basically the chairs report what's the main things going on, what are the things that require coordination. That could be one potential way to get more of that activity more widely available.
Yeah, let me just add one comment about coordination within the IETF. And in particular, where I think this group probably separates out a little bit. And it could be that we just want to evolve this group into something slightly a little bit more bound to the IETF, actually, which is that we have had numerous instances, I think, particularly with onboarding, but I'm sure it's happened elsewhere too, where different mechanisms are spawned in different working groups very early on. The director didn't see it until very late in the game, for instance. And having a way to spot those things earlier, to provide for common architecture earlier, probably would have helped, I think, prevent some fragmentation. So I just add that as a comment. I think Mohit, you're next.
Hi, Mohit. So I have been around the IETF now for 4.5 years. I have been attending all the meetings, and this is my view of things. So if I go to a BOF, people are all excited. There is 100 people in the room, and yeah, hum if you want to form this working group. The working group gets formed, excellent. But when it comes down to doing the things, I don't see anyone. Like there's only maybe 2 people driving the things, no people reviewing. And Elliot and I have been involved in writing the blog post that Steve writes, and we have trouble getting even people to write text for the blog. Like, am I living in some fantasy land where there's like a lot of people excited, but nobody sticks around to do the things? So we have experience of this on several occasions where people don't show up to do things. I mean, look at T2TRG. There is plenty of time to present new things, but who are writing the drafts and bringing it to the T2TRG group, right? I think this provides an excellent opportunity to get feedback from a diverse set of people, but who is making the effort to do that? So before we go around forming new working groups, whether they are coordination groups or new working groups on onboarding, why don't we bring those things here and try to like get feedback here and see like if this is not sufficient, maybe then forming a working group might help. I had couple of more things and then
let me stop you just on that one.
Please
for just a
let me
moment.
finish, and then you can address all my comments together.
No, I don't want to do that, Mohit, because I won't be able to keep them in my head.
I have notes, so I request you to take notes as well.
Yeah, but I don't. So just stop for a second. And the only comment I wanted to say was for IoT onboarding, we've had 3 meetings this week with, I'd say 20, 25 people in the room for each of the meetings. So we have probably, I think we're seeing a pretty consistent interest. And it's not, the goal there, I don't think, is to come up with a new standard, right? It's maybe a little bit here and there, but mostly to leverage the existing standard. So in that case, I think we have enough interest to move forward. All right, go on with your next comment.
Disappointing. Anyways, so we at the IETF build building blocks, right? And we let people to choose that. Maybe we want to change that. I'm not saying we should always, this is something that's written in stone and we should never like try out new things. But like there is Lake, the working group on lightweight key exchange. There is Compact TLS. there is IPsec, there is TLS. We have so many security protocols. We don't go and tell VPN providers to use IPsec and not use TLS or one or the other. We let them make the decision for them. So what I'm afraid also here is that if we start doing system architectural components documents, we are making the decisions for people, whereas we should let them make the decisions for themselves. So that's another point I think I wanted to make. I took notes as well, so let me.
Okay, Mohit, if you can be brief, we have only 5 minutes session left.
Sure. Yeah, maybe I will conclude by saying bring the documents to T2TRG, whether we want to have a focus working group on onboarding or whether we want to have more general, broader thing on IoT and systems. I'm not saying no to it. I just think like there's plenty of time in T2TRG to do a slow start here.
I'll just point out that there isn't because we're just about out of time, by the way. Okay.
So, Eric Nordmark. I mean, I think that on the IoT network onboarding, and I say network onboarding because I think that's been the focus of the work to date, right? That sounds like engineering and something that people can put together in a focused working group. There is a question about when you talk about onboarding in more general, right? What resources do I get access to? Who does this device actually belong to? Does it belong to Eric? Does it get access to the video camera at the door, the thermostat, whatever in the house? That might be a bit more researchy. I don't actually know, right?
We've done some of that with MUD, right?
Yeah.
But so we've already produced a standard there.
But it's not the manufacturer that decides who can access the camera at my front door, right? That's me. Mm-hmm. But how does the device belong to me? Well, I can come up with schemes, but it's not obvious that there's one answer, and it could be different for different domains as well, different use cases, right? So maybe figuring out where that boundary is a useful thing, but starting with the network onboarding. I don't know about the sort of general inbound, let's have a place in the IETF to discuss IoT as a working group. Is that you have to have some motivational factor to have people show up and actually try to do something, even if that's writing some documents that describe what they think is the shape of that part of the world, right? There has to be some motivation that drives focus in there, and I think IoT is way too broad for that. But so, thanks.
Michael Richardson here. So I mostly agree with Mohit. We should probably make more use of T2TRG. I would particularly like to know the Friday schedule, pre-meeting schedule, at least 4 months in advance so that I can adjust my other Friday pre-meeting schedule people around. Would have been there. I would have tried harder to be there last week if I'd known more than 3 days in advance. But so I think we actually need that big, long time. As Elliot said, we're running out of time right now. I actually think there's very little value in having the T2TRG meeting, this one, here, now. I think that it needs the whole day to discuss. The second thing is that I think that T2TRG has been focused on particularly like wishy type things like McCool's and Kostik's presentations earlier, and while I find them fascinating, I'm not a participant in that, and I think we need to branch into other bigger things, and I think this is the way to do it. But I wanted to respond specifically to the systems question. The IETF does do systems architecture. We have routers on the internet. They're stupid, and we thought they were, and we have endpoints, and that's a systems things, and the internet doesn't operate without the fact that there are routers that move layer 3 packets around. And the problem we have in all of the onboarding system proposals and the pushback we get, as Eric just alluded to, how do I onboard, what do I onboard to? We have not described a systems architect that says that a network owner, including a homeowner, will have a thing that onboards devices. That's a system level decision and we're getting pushback on that. Even in the enterprise space, Elliot, it's hard to convince them that they need to have a registrar or an AA server or a whatever. It's like, how can I get around without that? Please redesign your protocol so you don't need one of those, right? Mm-hmm. And so we need to have and other groups are looking to us to describe an architecture for how that works. That's a system level description. And once we say that there will be a foo where you join things together, we can argue about the engineering question of whether it's radius or diameter or Brewski or this or that, or maybe it's all of the above, right? Getting the system to host that installed is the hard part. Teaching it to learn new protocols is probably relatively easy.
Yeah, I'm just going to comment on one thing that's somewhat pedestrian, I suppose, in response to Eric and Mohit as part of this, Michael, which is anytime you want to form a new working group, I think of any form, there should be a couple of drafts floating, at least one draft floating around, probably a couple of drafts floating around. And so just to give you an idea, one of the actions we took out of all the meetings that we had this week is that we do need an architecture draft for how these things can fit together. Mohit, that doesn't mean that is the only way things can fit together, but that it is at least one way that makes that is sane. So with that, please.
Okay, two comments. So one on the architecture idea, and the other one on the T2TRG. So I think there is a interesting balance between having a systems view and doing all the architecture specification or standards watch activities that you mentioned in the beginning. So all those components that you mentioned, I mean, these are not really complementary components. This is a bag of things that you could pick one or the other and combine them in different ways. And so as a maybe example from a different technology field, I mean, there is certainly there are things going on outside the IETF, as you mentioned, and so what other groups do quite often is that they build something like reference implementation, reference architectures, quite often in what used to be called forums or these times open source projects. So that, I mean, of course, there are quite many already, but that could be another idea. So I'm 100% convinced that the IETF should really survey all those things and try to come up with proposed architectures. I think the IETF would be really good in enabling, a group of companies or institutions to work on very specific things, and they don't even have to fit together. So not everything we do in the IETF has to fit together into one system. So that's, I think, not really necessary. The other thing is T2TRG. So there seems to be some utility in this, little updating what's going on in the different groups. On the other hand, I mean, this is the IETF. We shouldn't forget that. I mean, there's also a place for research. So I'm not sure it's a really good idea to develop this group further to a coordination or surveying activity.
Mohit, we are already over time, so I won't make any long comments. I was reading through my notes and I got distracted because Jaime sent me a telegram. I agree with you on the lack of participation, 100%. I think one final comment, we have bigger problems to solve before we go around making an onboarding working group. Can somebody tell me the difference between onboarding, or Brewski calls it bootstrapping remote key infrastructure, or you mentioned DPP, which is device provisioning protocol. So what's the difference between provisioning, onboarding, bootstrapping, configuration, initialization? I think once we have that sorted out, maybe we can actually move on to onboarding.
Okay, I think you just described four things which are, roughly speaking, synonymous, and that we've had that discussion, though we haven't documented it. So I don't think it's bigger. I just think we know we have a particular problem in network level onboarding, which is that we have fragmentation, which is leading to confusion in the market, which is leading to slow roll deployments or no deployments at all. And so that's something that we have a real problem. That's the big, for me at least, that's the high order bit, which is that we're slowing ourselves down, and that systems level view might actually help that. This having been said, I want to thank people for their time. Ignis, I think you've heard the feedback here. I think it's probably worthwhile to talk about where we want to talk about this next and what our next steps are.
So one thing, Ignas Bogdanas, one thing that I will notice is IRTF group meeting here. So I think I'm here on the rights of a tourist. But what I hear from the feedback on those two topics, IoT onboarding working group, I think it's much more clear that clear of what to do next with that. Now the IoT systems thing, it's much higher of the contention and not that obvious, at least for me at this point in time. The comment about the documents and explaining the mapping between those and basically how those different things are there's different names for the same thing and how, I think that's a valid one. And maybe the proponents could try to address that, basically trying to describe their view of how these things differ, work together, and how what is the relevance between them.
Okay, thank you guys. Unfortunately, we're running horribly over time, so we have to cut it this time. But let's continue the discussion here on the remaining days and on the list. And on, I think clearly there's something interesting things to be done. We're very happy to host a lot of these discussions in the RG. One quick comment on that. We usually tend to have a lot of time on the agenda until like week before the meeting. So if you are a bit ahead, send us a request that, okay, here's a set of topics we'd like to discuss. Usually we're able to accommodate that. Both goes for the Friday meetings and also for the summary meetings. So, but then of course, if you want to go standards documents, etc., then it's going to need to be a different kind of group. But with that, thank you everyone for joining today. Looking forward to see you again later on our online meetings or our future face-to-face meetings. And if you haven't signed the blue sheets yet, please do so. We have them here in the front. Thank you and see you next time.
Thanks a lot.